children. After about 2 weeks, I came to see you for a new lesson, right? Then most of the children asked me how to write the redox equations. How to write the redox equations and how to balance them to obtain the balanced ionic equation, right? So, how to write the redox equations, then how to obtain the balanced ionic equation from the redox equations. Because to do the problems related with the stoichiometry and the concentrations, you must know to write the redox equations very well and to obtain the balanced ionic equation, right? Then, what is the meaning of the redox? Redox. See here, R-E-D-O-X, redox. Redox means reduction. Plus oxidation. Reduction plus oxidation. Reduction plus oxidation becomes redox. Redox means reduction and oxidation both. Redox equation means reduction equations and oxidation equations, right? Then, what is reduction and what is oxidation? See you first, oxidation. Oxidation is the increasing of the oxidation state or oxidation number of an element. Increasement of the oxidation state or oxidation number of the element. It is the oxidation. Reduction means opposite of that. Decreasing of the oxidation state or oxidation number of an element. So it is clear that increasing of the oxidation state is the oxidation. Then if we write the balanced ionic equation to show the oxidation, it is the oxidation half reaction. Similarly, decreasing of the oxidation state is the reduction. If we write the balanced ionic equation to show the reduction, it is the reduction half reaction. Why we named as half reactions? Half means half total. One means one is the total reaction. Always total reaction occurs with the two reactants, right? One reactant gives electrons, remove electrons, other element gains electrons. Exchange of electrons occur during the reaction, right? Then removal of electron is the oxidation. Gaining of electron is the reduction. I'll show you examples. See here, if we iron becomes Fe2 plus. Fe2 plus ion. How it becomes? With the removal of 2 electrons. This one has the 26 electrons and 26 protons in the nucleus. Then it removes 2 electrons. Now it has the majority, 26 electrons, 2 protons, then the electrons. So it shows the 2 plus charge. To balance it, we must add 2 electrons here. These are the removed electrons by the Fe element. This is the balance half reaction, ionic reaction equation to show the formation of Fe2 plus ion from the Fe atom. Then what is happened here? Oxidation state of Fe is 0. Now it becomes plus 2. Then I told you that increasing of the oxidation state is the oxidation. Now Fe undergoes oxidation with the removal of 2 electrons. Then removing electrons to increase the oxidation state, it is the oxidation. So the oxidation half reaction can be shown like this, right? Then see here, similarly, O becomes O2 minus, oxide ion. It gains 2 electrons. During my previous lessons, I told you, I had explained you, some elements remove electrons Y, some elements gain electrons Y. So you can refer my previous videos, right? Then, when oxygen becomes O2 minus, how? Now it has excess 2 electrons with the gaining of 2 electrons. Now, what is happened? Oxidation state of O is 0. Now it becomes minus 2. Then, decreasing of the oxidation state of oxygen occurs. This is the reduction. This is oxidation. This is reduction. Then it is clear that during the oxidation, removal of electrons takes place. During the reduction, gaining of electrons takes place. Due to that, increasement of the oxidation state occurs, decreasing of the oxidation state occurs during the reduction, during the oxidation, right? This is the explanation of oxidation and reduction. Then you must keep in your mind, always when we write the half reaction for the oxidation, electrons should be added to the right side. It never changes, to the right side. During the reduction, electrons should be added in the half reaction equation to the left side. So it is clear that, right? Electrons are adding right side during the oxidation half reaction. Electrons are adding to the left side during the reduction half reaction. Right? Then, why explain as the half reactions? Because oxygen needs 2 electrons. If we remove 2 electrons, these 2 electrons can be taken by oxygen. Then to form Fe2 plus and O2 minus, two electrons, exchange of two electrons was happened. Two electrons removed by Fe atom, oxygen atom gains these two electrons. Exchange of electrons happened. Right? This is the reaction. I think now you are clear that this is the oxidation of reaction, this is the reduction of reaction. Right? Then, shall we go to examples, complex examples, few. Then I'll explain you, these are the two very simple reactions, how to write the balance half reaction. Right, as an example, I'll give you when KMnO4 in an acidic medium, H plus, acidic medium, KMnO4, it has a purple color. Purple color. When we allow to react with the KMnO4 with Fe2 plus, Fe2 plus can be taken FeSO4. So you can observe that they react to give color change from purple to colorless, mainly. Purple to colorless. Right? Then, KMnO4 ionizes to give K plus MnO4 minus. Permanganate ion. This has the purple color. Purple color. Right? Then FeSO4 gives Fe2 plus. It reacts with Fe2 plus. Then, during this reaction, potassium exists as an inactive. Right? Initially K plus, finally also K plus. So the active species is MnO4 minus. Then MnO4 minus reacts with Fe2 plus. Then we consider the balance ionic equation. We can go through this equation taking MnO4 minus and Fe2 plus. Right? So, MnO4 minus becomes, the purple color becomes colorless. Colorless sign is Mn2 plus. Colorless sign is Mn2 plus. Right? Then we must know that during the reaction, MnO4 minus becomes Mn2 plus. Then what was happened here? So oxidation state of MnO4 minus, what is the oxidation state of Mn? You know how to calculate the oxidation state. So it becomes plus 7. Mn2 plus has the oxidation state plus 2. During the reaction, MnO4 minus complex ion becomes Mn2 plus. Decreasing of the oxidation state. Decreasement of the oxidation state occurs. So this is a reduction. Reduction. right? According to the color change, always you must know that always Mn4 minus should be reduced to form Mn2 plus if it is purple to colorless. But you must know that MnO4 minus is unable to oxidize because in MnO4 minus Mn is at the highest oxidative state plus 7. Then it has the ability to fall down O but never up increasement. Right? Then now I'll explain you how we balance this equation. There are different methods, right, to balance the equation, such ionic half reactions, right? But I'll tell you most appropriate method or easy method, right? MnO4 minus Mn2 plus. Now first of all, we must balance the elements. This side has one Mn atom. Here also one Mn atom. If there is a plus 2 charge, we consider only the elements. Mn1 atom, here Mn1 atom. Now Mn is balanced. Don't think about charges. At the first step, you must think about elements only. Then, oxygen 4 atoms here. Then we have to balance oxygen. Then as a rule, I'll tell you, to be balanced oxygen, we must convert oxygen to water. So it is very easy. Oxygen should be converted to water. Then O4 to be balanced, how many water moles should be formed? H2O 1 mole to be the O4 here 4. Now MnO4 minus converts to Mn2 plus and 4 water, Mn balance, O4 balance. During the balancing, addition of hydrogen, 8 hydrogen takes place. Addition of 8 hydrogen takes place. Then, after that, next step, first step, balance the elements. When you are going to balance the oxygen, you must add water to be balanced oxygen. During the balancing oxygen, adding water, it is definitely occurs addition of hydrogen. Now you have to balance the hydrogen. 8 hydrogen here. To be balanced the hydrogen, you must add H plus. H plus should be added. Then how many H pluses? 8. Because 4 hydrogen. 4 into 2, 8 hydrogen. To be balance the hydrogen, we must add H plus. So 8 H plus should be added. 8 H plus. Now see here. Mn balance, oxygen balance, hydrogen also balance. Now all the elements are balanced. Then find out the net charge of this site. Charge of the products. 2 plus. Plus 2. No any charge. This side 8 plus 1 minus. 8 plus 1 minus. So, I'll erase the auxiliary state. Now not need. Now, then charges this side 8 plus minus means plus 7. Product side has plus 7 charge. Reactant product side has plus 2 charge. Reactant side has plus 7 charge. Then finally, we must balance the charges. How we balance the charges? Plus 2, plus 7. Then, to be the plus 7 here, we must add plus 5. No, plus 7, plus 7. How we add plus 5? Plus charges are the protons. Then we must add protons. Then you know that, my dear children, protons are unable to add because they do not involve for the reactions. Protons because they are in the nucleus. Right? So we never add protons during the balancing. Then always we must add electrons. Exchange of electrons takes place. Then you must think, by the addition of electrons, how we balance both sides. How we balance both sides. Plus 2. Then, if we are able to decrease that plus 2 to plus 7 to plus 2, so it is balanced. Then this can be done adding 5 electrons. 5 electrons cancelling out with 5 protons, remaining 2 protons. So it becomes plus charge, plus 2. Then both sides are having plus 2, plus 2. How? With the addition of 5 electrons. Then I can write here 5 electrons like this. This is the balance equation. This is the balance equation. So, I told you that during the reduction, addition of electrons takes place. Addition of electrons. If the reaction is complicated but addition of electrons takes place during the reduction, this is Mn undergoes reduction during this reaction. This is the reduction, half reaction, to show the Mn04 minus becomes Mn2 plus. Color change, if we consider the color change, purple color becomes colorless. Then I'll tell you the very important thing, every year after that, okay, this reaction was given for every year, right? This reaction should be taken to do the problems by the students, right? Then you also, in this year also, it will come, definitely, right? Then this is the half reaction for the MnO4 minus. Then I'll tell you again, first write the MnO4 minus becomes Mn2 plus, you must know that. Then balance the elements, to be balanced the elements O4, you have taken water 4 moles, then 8H comes, so to be balanced the hydrogen, 8H plus should be added to this side. To be balanced the charges finally, plus 2 only, then to be the plus 7, 5 electrons should be added to this side. Now both sides charges plus 2 plus 2. This is the balance half reaction. Right? Then if we add to this solution Fe2 plus Then think about that. Fe and Fe2 plus and Fe3 plus are both can react with, are both undergo the reaction. Then you must think MnO4 minus should be reduced. I told you. Because Mn is at the highest oxidation state plus 7, so it is unable to oxidize. It should be reduced. If it undergoes reduction, no oxidation for the chance for the oxidation, other one should be oxidized. Then, if we take only 3 plus, Fe3 plus, it also should be converted to Fe2 plus because iron has 3 plus and 2 plus. The MnO4 also should be reduced. Fe2 plus also should be reduced. So it is unable. But the solution contains Fe3 plus and Fe2 plus also. If Fe2 plus undergo, it is unable to oxidize, but Fe2 plus can oxidize, converting Fe3 plus. So, then what is the reaction? MnO4 minus undergoes reduction, while Fe2 plus undergoes oxidation. Then, we can write the equation Fe2 plus becomes increasement of the oxidation state. Fe becomes Fe2 plus. Now Fe2 plus can convert to Fe3 plus. So it undergoes oxidation. How we balance the equation? This side has plus 2, this side has plus 3. To be plus 3 this side, we have to add protons. It is unable. But we can reduce 3 plus to 2 plus by adding an electron. So this is the balance half reaction for the oxidation. I told you, during the oxidation always occurs the addition of electrons. Right? Addition of electrons to the product, oxidation, addition of electron takes place to the reactants during the reduction. So these are the two reactions, oxidation and reduction. These are the half reactions. Then we can add now. During the addition I told you, here if we gives 2 plus 2 electrons, then that 2 electrons can be gained by oxygen. No electrons, right? Excess. Here also, iron Fe2 plus needs 1 electron to be converted to Fe2 plus. During the reduction of MnO4 minus, 5 electrons required. Then these 5 electrons should be given by Fe2 plus. Then 1 Fe2 plus undergoes Fe3 plus to form 1, giving out 1 electron. To give 5, it should be multiplied by 5. Then you must know that in mathematically we must know equalizing the electrons finally by multiplying 5. Then electrons are cancelling, right? Then 8H plus MnO4 minus 5Fe2 plus as the reactant. As the products, Mn2 plus 5Fe3 plus for water. This is the balance reduction of reaction. This is the balance oxidation of reaction. This is the balance ionic equation. To do the problem, we must obtain that final balance ionic equation. So it is clear that 8H plus 1 MnO4 minus 1 mole of MnO4 minus react with 5 moles of Fe2 plus. It occurs 1:5. Then we can go through the calculations. Right? I did this type of calculations by my previous videos. Okay? Then it is clear that no. Then shall we go to other equation also? Right? To be balanced. Then see here, MnO4 minus undergoes reduction with Fe2 plus. With Fe2 plus. So this reaction occurs with sulfur dioxide gas also. If we take a solution of acidic KMnO4, it has MnO4 minus ions. Then if we pass SO2 gas through this solution, it becomes purple to colorless. That means this reaction is occurred. Reduction. You know that MnO4 should be reduced. Okay? Then SO2 undergoes oxidation. SO2 gas undergoes oxidation. Shall we go through this equation? Right? Then you must write the oxidation of SO4 2 minus. SO2 gas to SO4 2 minus. SO2 gas undergoes oxidation to give SO4 2 minus during the reaction. So see here, if we calculate the oxidation state of SO2, S becomes plus 4. Here, SO4 2 minus S becomes plus 6. Increasement of the oxidation state. So it is the oxidation of SO2 converting SO2 to SO4 2 minus. Then shall we go to obtain the balance oxidation half reaction? So what should be done first? Elements should be balanced. Sulfur 1 atom. Sulfur is balanced. Oxygen 2. But this side has how many oxygen? 4. Then do we remember how we balance the oxygen? Adding water. It is the method to balance the oxygen, addition of water. Right? You can't balance adding 2, right? Then to be balanced the oxygen, here also should be added required amount of water. 4 oxygen, 2 oxygen is present. To take 2 other oxygen atoms, how many water moles should be added? 2 water moles. If you add 2 water moles to the SO2, 2 water moles, now it is balanced. Oxygen 2 to 4, oxygen balance. Sulfur also balance. Then, as before, what occurs? During the addition of water, addition of hydrogen takes place always. Then you have to balance the hydrogen. So what is the method for the balancing of hydrogen? Addition of H plus. Addition of H plus. Then to be balanced 2 into 2, 4 H atoms, you must add 4 H plus to this side. 4 H plus to this side. Now sulfur balance, oxygen balance, 4, 4, hydrogen, 4, 4, hydrogen balance. As before, here also same, elements are balanced, right? Then what is the charge? No charge this side, 0 charge, but this side has plus 4, minus 2, plus 4, plus 4, minus 2. What is the net charge? Plus 2. Then this side has plus 2 charge. Plus 2 charge. This side no charge. Then how we balance the charges of both sides? It is unable to give plus 2 here. So should be added the protons. I told you we are unable to add protons, but we can neutralize that 2 protons with the addition of 2 electrons. If it's so, add 2 electrons to this side. 2 electrons to this side. Then 2 minus, electrons also 2 minus, 4 plus, 4 minus, 4 plus, no charge, no charge. See here, in this case also occurs the addition of electrons to the product side, right side, because it is an oxidation. See here, oxidation, we have to add electrons to the product side. Now, I think you are clear that how we obtain the 2 half reactions, reduction of reaction and oxidation of reactions. Always to be balanced them, first elements should be balanced. Then to be balanced the oxygen, you must add water. To be balanced the hydrogen, you must add H plus to the required side. Then we must add these 2 equations. As before, then you must know that here, during the addition, 5 electrons needs 2 electrons given. Then to be balanced, 10 electrons should be given, 10 electrons can be taken. 5 to 2, the common factor. How we cancelling out the electrons, multiply by 2 and multiply by 5. Then electrons are cancelling, then you can write the reactants and products, right? Then see here, 8H plus means 8 into 2, 16H plus in this side. MnO4 minus 2. 2MnO4 minus. 2MnO4 minus. 5 into 2, 10 water. 10 water. 5SO2. 5SO2. These are the reactant side. Product side 2Mn2 plus. 2Mn2 plus. 2 into 4, 4 water. 4 water. Plus 5SO4 2 minus. 5SO4 2 minus. Plus 5 into 4, 28 plus. 28 plus. These are the reactants and products. Then after that, what should be done? 16 plus 28 plus. So it is impossible, no? Then 16 cancelling with 16 remaining 4 plus. During the reaction, 4 plus is formed as the product, no reactant. 2MnO4. It should be present. 10 water, 4 water, then 4 water cancelling, out of 10, 6 water, remaining 6 water. 4 water cancelling, 4 water of the 10, remaining 4 water. This side has 4 water only. 2MnO4. 5SO2. No SO2 this side. Then it is clear that as the reactants 2MnO4 minus 6 water and SO2 5SO2. 5SO2. These are the reactants. So what is the product? What are the products? 2Mn2 plus 2Mn2 plus water cancelling 5SO4 2 minus 5SO4 2 minus plus 4H. This is the balanced ionic equation. This balanced ionic equation is enough for the calculations. So it is clear that MnO4 minus becomes Mn2 plus, reduction, purple color becomes colorless. Then see here, water and SO2 and H plus and SO4, that means sulfuric acid also formed. So this is the balanced ionic equation, final equation. So it is clear that it can be taken, so you can write, you have to add these two equations to obtain the final equation, right? Then I'll show you, I was explaining you two equations, how to obtain these two equations from the redox equations. Oxidation half reaction, reduction half reaction, how we write the oxidation and reduction half reactions, then by adding them, how we obtain the final balanced ionic equation, right? So, my dear children, that ability you must improve. Then, next day, I'll explain you more problems, how to show the calculation also, starting from how to write the balance half reactions and how to obtain the final equation and how we go through the calculations. I'll do with you by my next lesson. Right? Thank you for all. See you from my next video.